Now let's look at a few definitions that we're going to use throughout this semester course. A set S that's a subset of the real numbers is bounded above if there's a capital M such that x is less than or equal to m for every x in the set. Now, in this definition, I also defined bounded below in the same definition, so let's follow that path. The set S, subset of R, is bounded below if there's a capital M such that x is greater than or equal to m for all x in the set S. So we've got two terms being defined here, bounded above and bounded below. And then a set S is considered bounded if it is bounded both above and below. Another way of saying that is S bounded if there exists two different numbers, little m and capital M in the real numbers, such that x is between the two of them, less than or equal to the big one, greater than or equal to the small one, for all x in the set S. And the next definition says for a set S in the real numbers, subset of the real numbers, capital M is an upper bound or a lower bound for the set S if x is less than or equal to m, correspondingly x greater than or equal to m, for all x in the set S. So for example, in the previous definition of bounded, if it is bounded, capital M would be an upper bound. Little m would be a lower bound of the set. And remember, there's not just one upper bound or one lower bound. If capital M is an upper bound, then so is m plus 1 or m plus 5. A lower bound, if m is a lower, little m is a lower bound, then m minus 1 is also a lower bound. All right, let's look at these examples. Find an upper bound and a lower bound for all of the following sets, if possible. It might be that none exists. Well, here's a simple one. We got 3 elements in it. So one lower bound could just be the smallest number in the set, -2, or -3, or -5, or -1,000,000. They're all lower bounds. -2 is a special one, though. It is the greatest of all of the lower bounds, and we'll talk more about that in a few minutes. An upper bound, well, don't say 3. These aren't written in increasing order. So an upper bound would be the number 20, or 21, or 21.5, or 50, or 100, or 1,000,000. They're all upper bounds. The best possible upper bound I can think of would be the lowest upper bound, the least upper bound, which would be the number 20. This is the interval from -1 to 1. The lower bounds are -1 and any number smaller. The upper bounds are the number 1 and any number larger. C is an open interval. -1 is a lower bound. -1 is actually smaller than every single number in that interval. It's not a part of the interval. The number 5 would be an upper bound, or 6, or 10, or 1,000,000. Now this is an interesting case because there is no upper bound or lower bound that is in the set, like we had in the previous 2 examples. D, the set of 1 over n for all natural numbers n. So if you write those out, it makes it easy to see. It would be 1, 1/2, 1/3, 1/4, 1/5, and so on. It's a decreasing sequence, so the largest element is the first one in the set. So an upper bound would be the number 1, or anything greater than 1. Well, the number 0 is not in this set, but it is a lower bound for the set, and there's actually no bigger number that would also be a lower bound. So 0 is a good lower bound for that, or any negative number would be a lower bound. Well, these 2 are fairly simple. set of rationals and the set of integers, there is no upper bound, there is no lower bound for those. And we typically don't say the upper bound is infinity or negative infinity. So these are unbounded sets.